Segment 32, heat transport in the solar interior. The energy in the sun is generated by nuclear fusion at the very center of the sun, but that energy is only lost by radiation when the energy is transported to the surface and then radiated from there. So how does this happen? Nuclear fusion is taking place in the center and the energy has to get out. And the answer is it gets out any way it can. So we want to examine the various modes of energy transport in a gaseous body like the sun and try to understand how they work and if they can be effective. We start by considering conduction. Conduction happens due to vibrations inside of a dense medium. So the electrons in a metal or the atoms in the lattice of a solid will vibrate back and forth, striking the ones next to them and giving them somewhat more energy than they had. So energy is gradually transported down a temperature gradient from the hot end to the cool end. This happens very effectively in a metal where there are free electrons moving around inside the metal, but a very dense non-conducting solid like stone will be a very poor conductor of heat, and gases, because they have very low density, there's not enough collisions, are even poorer conductors of heat. In fact, this is one of the reasons why you wear a down jacket in the wintertime, is that the down in the jacket provides some space between the layers and allows them to be filled with air, and the air transports very poorly by conduction and provides you very good insulation. So in the sun, which is not particularly dense, conduction is not a very effective heat transport mechanism. Radiation works much more effectively. The illustration shows photons leaving a hot area in the fire and arriving at a cool one. Actually, photons are moving in both directions. Your hands are warm and they're radiating energy as well, but the dominant flow of energy is down the temperature gradient because the hotter things are much brighter and they send out radiation that then heats the cooler things. In the illustration shown here, this is an illustration where the photons can travel freely from one object to the other. In stellar interiors, however, the regions are very opaque and the light scatters around, and so it doesn't walk directly out. It random walks out, first getting to one particle and then scattering off and kind of going in different directions until it diffuses very slowly out of the center of the star. We'll be discussing this in class. But basically, when the star becomes too opaque, the scattering length is short, and the photons have to scatter many times in order to move outwards, and it becomes an ineffective means of transport. When that happens, the only form of transport that's available to you is convective cooling, and that gets set in motion by the very large temperature gradients that develop when the energy can't move outward in the sun by radiation. So convection is the phenomenon that occurs, say, in a pot of water when you have a flame under it that heats the water at the bottom of the pot, and that water becomes less dense as well as hot, and it rises, gives off its energy at the surface, and then cools and sinks again. So on the left, you're seeing an illustration of how this might happen to a packet of gas in the sun. It's very hot in the center of the sun, and if it's perturbed slightly upwards, it will expand a little bit. And if in the expansion it doesn't have to do enough work to cool off, then it will become buoyant, it will start to rise, and as it rises it expands even more, which allows it to rise through the lower density layers above, until finally it reaches a zone where it can give up its energy, either to radiating it into space or to another convective cell that's in action above it. When it cools off, it shrinks down a little bit. Now it's a little more dense than the gas around it, and it starts to sink, and as it sinks, it shrinks down, and if it shrinks down more quickly than it heats up due to the contraction, it will sink all the way back down to the beginning, and the cycle can start over again. And this is a good way to transport energy, by moving hot matter up and bringing cool matter down, and that's how convection works, and it's an important mechanism in the sun. So here we see a cartoon of the sun showing the energy being generated in the core, and then a radiative zone around it, which is not terribly opaque, and the light can scatter and diffuse energy outward until finally it becomes so opaque as the temperature gets lower that radiative transport becomes ineffective, and the strong temperature gradient there promotes convection, and convection then carries hot parcels of material up to the surface where they can again radiate away their energy and cool off and sink back down.